Homework to see, lesson 2.14. Problem 7 says refer to the diagram for exercise 6. Okay, so exercise 6 is in a textbook. So if you don't have a textbook with you, you can't solve this problem. But if you do, it says write one new statement either above triangle ABC or about triangle ADC and triangle BDC that guarantees that all 4 of the statements in exercise 6 are true. If you don't have one, you can't do this. Problem 8, describe the set of triangles that meets each of the following condition. The perpendicular bisector of exactly one side passes through the opposite vertex. What kind of triangle is this? Is it scalene or isosceles, or maybe drawing the diagram probably may help you. B says perpendicular bisector of each of exactly 2 of the sides passes through the opposite vertex. What kind of triangle is this? So maybe you can draw different triangles and examine, do some experiments. Draw equilateral triangle to see if this is true, or draw different kinds of triangles to see if this is true. And the C says the perpendicular bisector of each of the sides passes through the opposite vertex. I kind of feel like, okay, each of the sides, all of the sides has to pass through the opposite vertex, so that must have a beautiful triangle. He also said that you may find it helpful to construct some triangles that meet each condition, and that's exactly what I said. And explain what you find. Okay. Problem number 9 says use a cup of glass to trace a circle on a sheet of paper. Explain how to find the center of the circle. This is actually possible, and if you could find it. Problem 10. Brittany found a piece of broken pottery that looks like part of a circular dinner plate. She wants to determine the radius of the plates, but she has less than half of the plates. First, she traces the outline of the outer edge of the pottery on the sheet of paper. Then she draws 2 line segments with endpoints that are on the different parts of the carve. Next, she constructs the perpendicular bisector of each line segment. She extends the perpendicular bisectors until they intersect. Finally, she measures the distance from the point of the intersection of the perpendicular bisectors to point on the curve. Why does this procedure guarantee that she has found the radius of the plate? Okay, so we have a curve like that, and you take 2 points and draw line segments like that. Okay, and then you draw perpendicular line to that and a perpendicular line to that. Oh, it doesn't look like perpendicular. And if you extend that, see, it's going to intersect somewhere. And they said from here to here, okay, so that the endpoint to the intersection guarantees that's the radius. And why is that? Choose the answer from C, A, B, C, or D. Problem 11. Describe an algorithm that you can use to construct a circle that passes through a vertices of a given triangle. So problem that's 11. So any triangle, you have 3 vertices, and there's a way to draw a circle that passes through those 3 points, even though I'm doing a terrible job. So how do we do that? That's problem 11. And problem 12, a circular saw blade shattered. Or you can find a piece that looks like the figure at the right. Explain how you find the diameter of blade so you can buy a new one. So you can use the idea from problem number 10. Problem 13, show that if the hypotenuse of and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. This test for right triangle congruence is sometimes called the hypotenuse leg and is abbreviated HL. So how is that true? Problem number 13. So it's right triangle and hypotenuse and one leg are congruent to the other, and we know it's 90 degrees. So why this guarantees the triangle congruence? It's kind of obvious. Problem 14, draw several triangles. In each triangle, construct a perpendicular bisector of each side. So problem 14, draw several of them, like 2 or 3. Draw a perpendicular bisector, take the midpoint and draw a perpendicular line to that. And notice that the perpendicular bisector in each triangle intersects in one point, so it's concurrent. Right? Is this true for all triangles? And why? So if I draw some different kinds of triangle, take the midpoint because of the bisector and draw a perpendicular line, it seems that it looks like, well, I'm not doing a good job, but it looks like it's meeting at one point. And provide a proof. Number 15, perform paper folding construction. Shown at the right, start with the rectangle and follow the direction and prove that any point on segment CD is the same distance from A as from B. Okay? So, yeah. If you take any point on CD, the distance from A will be the same as from point A to that point on CD will be the same as CD. So let me just explain that part. So you got this and you've got that figure. If you take any point on CD, okay, the distance between A to D will be A to that point P to the distance from P to that B will be the same. So for example, if you take points right here, the distance from B to that point and to A will be exactly the same. But why?